Newton's second law of motion is an equation that tells us that the acceleration of a body depends directly on the net force the body receives and indirectly on the mass of the body. This presentation will focus on how the mass of a body affects its acceleration. Newton's second law equation tells us that only unbalanced forces cause objects to accelerate. It also tells us that the net force on an object is directly related to the acceleration that it produces. This simply means that if you double the net force on an object, you will double the acceleration. Which bodies are accelerating? Newton's second law tells us that only bodies with a net force whose magnitude is greater than 0 accelerate. Choice A, B, and D must be accelerating. Newton's second law also tells us that the more mass a body has, the more difficult it is to accelerate. An object's resistance to a change in motion due to its mass is called inertia. Inertia and mass are directly related. A body with 10 times the mass of another body will have 10 times more inertia and be 10 times more difficult to accelerate. Once again, inertia is an object's resistance to a change in motion due to its mass. The person in this animation applies the same force to the two carts. It's no surprise that the cart with the smaller mass receives the greater acceleration. The smaller cart has less mass and therefore less inertia. A smaller inertia means that it has a smaller resistance to a change in motion due to its mass. Unbalanced forces change motion, speed, and/or direction. Why is it so difficult to pedal a bike when you start from rest? Everybody who has ridden a bike has had a first-hand experience with inertia. It is so difficult to pedal when you start out on a bike because of inertia. The combined mass of your body and the bike make changing your speed difficult. The mass of you and your bike resist a change in motion. So why is it so easy to pedal once you reach a constant speed? It's so easy to pedal because the only time you experience inertia is when you're trying to change the motion of an object. Remember, inertia is the resistance to a change in motion due to an object's mass. Once you reach a constant speed, you no longer experience the inertia, and you only need to apply enough force to equal the total friction on you and your bicycle. Let's review. Inertia is an object's resistance to a change in motion due to its mass. The larger the mass, the greater the inertia. Inertia and mass are directly related. Twice the mass, twice the inertia. Why are the most massive football players linemen? Linemen who protect the quarterback bulk up so that it's very difficult to change their position. Linemen tend to be more massive because they want to have more inertia. Why are the least massive football players receivers? The receivers on a football team tend to have less mass because they attempt to elude the defenders by changing their speed and direction. The less mass you have, the less inertia you have, and the easier it is to change your speed and direction. Rank the carts below from greatest inertia to least. Explain your answer. All you need to look at when you rank the inertia of these carts is one thing. Ignore everything else you see in these choices except mass. The cart whose motion would be the most difficult to change would be choice D. Choice D has the most inertia because it has the most mass. The cart with the least inertia, of course, would be choice A because it has the least mass. If all these carts received the same force, cart A would receive the greatest acceleration because it has the least mass. Let me summarize the key points of this presentation. Inertia is an object's resistance to a change in motion due to its mass. Only mass determines inertia, and mass and inertia are directly related. This is the end of my presentation on the second law of motion and mass.